Okay, I'm recording now. Sorry, thanks for reminding me. So I just mentioned that today's code is available in the Moodle, day 4, and also on GitHub. Yes, so here on the Moodle, and then also here in GitHub. The day 4 is updated here. So right now we're going through the day 3 homework. So Danya just so we have the fruit amount equals the length of fruits, vegetable amount equals the length of vegetables. Okay, so while length of fruits does not equal length of vegetables, if the length of fruits is less than vegetables, then we're going to add a mango. And if the length of vegetables is less than length of fruits, then we'll add onion. Okay, that's great. And actually, I think in that case, since you're using length of the list, we don't actually need these variables, right? So we can get rid of those. And let's
forget to remove them.
We have to run. Great. And so we can verify that there are 1, 2, 3, 4, 5, 6 fruits and 1, 2, 3, 4, 5, 6 vegetables. Great. Okay. Great. Let's okay, for this, and then use a Boolean flag, and if to report when we're done. I don't think we can just skip this one. Let's see. Okay, so if vegetables don't equal fruits, use if and other every different solid once. Okay, so how about exercise 2? Lunar has code for that.
It is for the first one, Boolean flag.
Okay. Layla, you mean? Oh no.
No, mine is for the second exercise.
Okay. All right. So this is the up here, right? So if length vegetables equals length of fruits, then print number of vegetables equal to fruits. If vegetables is greater than fruits, there are more vegetables than fruits. Okay. So we could actually we could include this like in here if we want. Just give us an update. Oops, sorry. Right, and you could say so there are more fruits and vegetables. Yeah. Yeah, so we added an onion to vegetables. There are more fruits and vegetables. So we added an onion to vegetables. There are more fruits and vegetables. So we added an onion to vegetables. Yeah, so you're just playing with that. Okay, so that's good. So for exercise 2, let me see. Yeah, let me use Glowmiller's code here. Okay, so if the length of vegetables is greater than the length of fruits, then the difference is this, and then we're going to add that much pineapple, right? And if, okay, so I think, first of all, let's take this difference and let's put that up here. So difference equals length of vegetables minus length of fruits, right? And then, because now for the if and the elif, we don't have to calculate that difference a second time, and we can use the difference. So if difference, let's say this difference is positive, right? So if we have more vegetables than fruits, then diff1 is going to be positive, right? So if diff1 equals 0, is greater than 0, that means in this case, more veggies than fruits, then we need to add diff1 fruits, right? So in that case, fruits plus equals diff1 times pineapple is right. So that's fine. And then elif, and then here we can still use diff1 again, right? So diff1 is less than 0. Now we have more fruits than veggies, right? If diff1 is negative, that was, say, like we had 4 vegetables and 10 fruits. Now 4 minus 10 is going to be minus 6. So if diff1 is less than 0, then we have more fruits than vegetables, and we need to add but diff1 is negative, so we would need to add minus diff1 vegetables, right? So in this case, vegetables, and then we could just do minus diff1. So, right, because say say diff1 is minus 6. Now diff1, does that work? So minus diff1 is that. So here, if diff1 is negative, then we need to add minus diff1 times tomatoes. So then that will give us that, right? Oops. Sorry, I have to run that again. Yeah, and so we started out with 1, 2, 3, 4, 5 fruits, and now we added, or sorry, 6 fruits and 3 vegetables, and so we added, so diff1 here is minus 3, and so since diff1 is less than 0, we added 3 tomatoes, so that's fair. Right? So here with the difference, you just calculate it once, and then you can use that variable in these if and elif statements. And then, else you can print, we have an equal number of fruits and vegetables. Which if we run it now should be the case because we haven't updated yet. Okay. And exercise 3. We're going to recode exercise 2 using dictionary instead of fruits and vegetables. So okay, so for exercise 3, I'll basically all I wanted you to do with exercise 3 was to just replace these with. Replace the list with the dictionaries. The reason why I'm having you do this quite a bit is because oftentimes, like, this is when you're dealing with like more complicated data structures, like for example, a dictionary with where the value is like a list. It's just easier to continue working with that dictionary in this way rather than like break out the lists separately. So I'm just kind of trying to get you in the mindset of working with more complex data structures. So it's the same. It's the same result, just replaced with those. Okay. Today, so this is any questions about these exercises, these homeworks? So today, I'm really excited about the topic because we're going to be able to start doing some really cool things when we start combining statements. So here today we're looking at for loops. I'm going to record I'll upload the video of this tutorial afterwards. We've covered primitive data types, non-primitive data types, the control structures if and while. Today we're going to look at for loops. We're going to combine if selection and repetition statements. So if and for, using if with for loops and if with while loops. We'll look at nested repetition statements, and we'll also talk about list comprehensions. And I think the homework, like the homework assignment for today is like probably the most, a lot more interesting than what we've done this far. So, so I want to start by defining a couple of functions that we're going to use today. We talked about these last time. Here is my produce report function where I input produce, and then I'm going to refresh the produce basket. This is all, it's just printing so like what's in the fruit basket and the vegetable basket and the produce basket all together, and then the number of fruits and veggies. So I just kind of adapted this from, we've been using this, but and then I also want to create a refresh produce function because we're going to be refreshing our produce every time we start a new exercise. And this, notice that this function does not have a parameter. We're not inputting a variable. We are just creating a variable inside fruits and vegetables, and then we're creating our produce basket, this dictionary with our list of fruits and our list of vegetables. And then this function is also doing something else. It's calling this function, right? So first we define this function, produce report, and then we're going to call produce report inside of this function, and we're passing in this produce dictionary, which we just created, and it will run the produce report on this new produce dictionary. Lastly, we're returning produce. So we've created this dictionary, and this function is going to return that dictionary, which means when we call it here, refresh produce, we can set a variable equal to this function, because this function is going to return a dictionary. So this produce variable will be assigned to this produce dictionary that's being returned by this function. Right? So let's see how this works. I'm going to run the function. I'm going to define this function. And you notice when I ran them, like nothing, it didn't do anything, right? It's just creating that function. And now we're actually going to call this function. And what's going to happen when we run this? What will the output be?
It will return produce report.
Yeah, it's gonna, it's gonna output this produce report because we're calling that here, right? So all of this stuff that we're printing here is gonna be printed as we produce these structures and return produce. It will also print out this produce report. So let's do that. So so it printed out this report, but it also did one other thing, which was assign this produce dictionary to here. So if we run produce now, right, it's the dictionary, right? So that this function did both of those things at the same time. Right? Okay, so we'll talk more about functions tomorrow, but I just wanted to kind of introduce you to them here. Okay, so today we're going to talk about for loops. Here's a useful some link that you can look at. So loops on lists, we can do for loops on lists and dictionaries. So let's refresh our produce. We can do a for loop. So produce is a dictionary here. So for each item in produce, we'll print the item. So what's this going to return? This is the dictionary, produce. What's this going to return if we do this for item in produce?
Fruits and vegetables.
Yes, because this item in produce is actually equivalent to these, to running the produce keys, right? Fruits and vegetables. What if we wanted to, what would this do? What would this do? What would this for loop return for item in
So it
produce?
return two lists.
Yeah, it's going to return the two lists because the value of fruits is this list and the value of vegetables is this list. So if you run these values, it's going to return two lists, right? Okay, so that's dealing with the dictionary keys and values. Now let's look at a list, right? So produce fruits is this list here, right? So if I print this out, what's the output going to be?
Fruits list.
Yeah, but it's going to be each item in the list separately. So it's not going to output a list, but it's going to out a list structure, but it's going to list all of the items in the list separately, one at a time. Right. So here, produce fruits is this list, right? And then for item in that list, it's going to take orange and print that, take pear, print that, take banana and print that, etc. So here's another thing. We don't just have to use a print function. What's this going to do? So I'm defining a string fruit list that says our fruit basket contains, right? And then for each item in the produce fruits, I'm taking that item and I'm doing something to it. What's this going to do?
It will add each item fruits
Yeah,
to the string our fruit basket contains.
right. So fruit list is this sentence here, this string our fruit basket contains, and then for each item in the list, I'm going to add to this string a space and the item followed by a comma. So if I print that, what's this going to say?
Our fruit basket contains orange, pear, banana, etc.
Yeah, right. So this is a kind of recursive. I'm recursively adding a fruit to this, right? So if I print out fruit lists within the for loop, then you could see the evolution of this sentence, right? So each time I'm adding it, you can see I'm adding a fruit with a comma, a fruit with a comma, a fruit with a comma, right? Okay, and then but this sentence is ending with a comma, right? Which is, so how could I, so if I run this, fruit list 0, 2, -1, that will give me the whole string minus that last comma. And then I could add on a period if I wanted, like that. Okay, so these are some different ways you can use the for list with a for loop with a list. So, but now I'm going to refresh this. For this problem with the period at the end, there's we could also use a while loop. With the length and pop. So I'm introducing this now because we're going to use this kind of structure with while, length, and pop like later. But we can use it to solve this problem. So say we want to add a fruit and a comma for all fruit except for the last one, right? For the last one, we want to add the fruit and a period, right? So for the while loop, we can use the length of, we need an ending condition, right? So something that will end the while loop. So we're going to use the pop function to pop the fruit out of the list. So each time we pop it, the list is going to get shorter and shorter and shorter. So while the list still has at least one element, more than one element, I'm going to add that element to the fruit list with a comma. But when there's only one element left in the list, when the length of the list is 1, it's going to exit the while loop, and that will mean I still have one element left in the list. And so after the while loop, I'll pop that last element and add a period, right? And that should give us the list with commas, and then except for a period on the last one. So here's what I want to show you is that you can use a for loop, looping through the items of a list one at a time. Another way to do that, it's kind of equivalent to using a while loop going through a list but popping items as you go. The difference is if I print out, so I can print out, oops, sorry, I need to refresh our code this last time. Right, so it does it in the same way, but if we also print out the produce fruits here, you'll also see with each sentence that the produce is getting smaller and smaller, right? Because we're popping items from the list. So these are two different ways of kind of navigating through the list. You can either do well, if I print the produce fruits here, let me just keep this on the same line maybe. I need to refresh. Right here, you'll see the produce list doesn't change, right? The produce list is the produce list is the fruit list is not changing, right? We're just looping through it. We're adding each item, but we're not changing it. But here it's actually getting smaller as we go. Okay, so these are two different things we'll keep in mind. We'll be using this logic again later. This gets smaller as we go. Okay, so we can also do for loops on strings. So here, instead of a list, we've got a string. So what's this going to give us? What's this going to run if we do a for loop on the items of a string?
Maybe letters of the words separately.
Right. So here, if you run a loop on a string, you're going to get each character separately. So here I've created T, which is I love. And then for X and Apple, I'm going to add X. And I'm going to print this out each time. Okay. And then I can print out this at the very end. I love apples. But why did this print function give me a space?
Because you need to have a backslash.
So
Because
actually,
of the comma.
because of the comma. Yeah. So for I love apples a lot. See, if you put these different pieces in, the print function, the issue with the print function, so I'll put this up here, there's a link here, is that the print function has all these objects, and then there's a parameter called SEP, which is a separator, and the default separator is one space. So that's why when you use print function, whatever you put in here, it's going to separate everything by one space, right? So just like up here, I wrote the fruit list, right? I wrote the fruit list and then produce, right? And you can see there's a space here, right? So print function always inserts a space between these things, unless you tell this, unless you redefine this separator to be no space, right? So if you do that, then it'll put them next to each other, right? You can also have this, you could have the separator be anything, right? And then it'll separate them with whatever you put in here, right? So the default is a one white space, which is why you get that. So if you don't want that, then you need to indicate separator with no white space. So that's just something, that's just something about the print function. But okay, so but you can use this. The point here is you can use the for loop to kind of to go through the items in a string as well. There's another way to go through for loops using the range function. So the range function is curly brackets, right? It's a function, and then you can specify the beginning and end of the range. Note that just like our indexing subslices of lists, it includes 0, excludes 5. So if for each item, the range is going to return the numbers between these two numbers, and then we're going to print that. So what's this function going to return?
From 0 to 4.
Yeah, so this will return 0, 1, 2, 3, 4, right? Range from 0 to 5, excluding 5. So if I define this list fruits, sorry, I need to refresh. Refresh my progress. Okay, so fruits. here, orange, pear, banana, kiwi, apple, banana, and the length of fruits is 6. So the C++ or Java way to loop through lists is with manually indexing the length of the list. So C++ and Java will use this kind of range function from 0 to the length of fruits, right, which is 6. So there's 6 elements in the list, and the index starts from 0. So this will go from 0 to 5, right? So 0, 1, 2, 3, 4, 5. So X, I'm gonna print X here, and then the fruits. So here, the index is 0, and then 1, and then 2, then 3, then 4, then 5, and the fruits of index 0. Right. So this is how C++ and Java use for loops with these indexes. Right? But the Python way is to loop through lists without indexing. So if you leave the indexing to Python. So here's the list of fruits, and you just do print item and fruits like this. You don't need to use the range function, and it will just print them out. So this is you can use the range function to index if you need to index, if you absolutely have to index for some reason, you can construct a for loop this way, but it's a very kind of non-Python way. So it's a very C++ Java way to use for loops. Okay, I don't have exercises for this. Okay, so now we're gonna combine selection repetition statements. So now that we've talked about for loops, we can use an if in for loops. So let's refresh our produce. We'll print out the items and fruits. Now it's going to start getting fun. So let's print out items having 4 or fewer letters. Right? So orange has 6 letters, pear has 4, banana has 6, kiwi has. So let's well, first of all, let's print out length of, we call this item. Right, so this is we can use length of item. This is the length of right, orange has 6 letters, pear has 4 letters, etc. So let's print out the items with 4 or fewer letters. So for item in fruits, just use a singular here. If for each item in fruits, if the length of the item is less than 5, then we'll print it. Right? So that prints pear and kiwi because they have fewer than 5 letters. Right? Okay. Would you like a fruit smoothie? So for item in fruits, let's run these sentences. Would you like an orange smoothie? Would you like a pear smoothie? Okay, so, but what's wrong with using A for all of these sentences?
Should be an orange.
Yeah. So
Yeah.
if it starts with a vowel, it should be an, right? So how can we vary the article a or an depending on whether the first letter begins with a vowel? So here's the code from above. So to adapt this, first of all, we need to define vowels, right? So vowels are A, E, I, O, U. We don't have Y here, so I'll just leave Y alone. And then if the first letter of the fruit is a vowel, so I'm going to write some pseudocode here. If the first letter of the fruit is a vowel, then insert n. else insert A. Okay, so this is kind of my pseudocode. So I know I'm going to need an article, either A or an. So I'm going to define that article here as A. And then well, I guess I can just, I guess I don't have to define it. I can just say, so how am I going to get the first letter of the, how can I test if the first letter of the fruit is a vowel?
If is okay.
Sorry. Maybe the same as you did with Apple, like when each word, each letter was separate.
Uh-huh. So, but in this case, for each item, as we're looping through each fruit, right? Orange, pear, banana, kiwi, apple, banana. I only want the first letter of that fruit. So how do
Lengths minus minus one lengths.
Okay. Let's try this. So let's say item equals apple, right?
We want to
So-
take 0 element of item,
Yeah,
like
that's
the
right.
first.
That's right. So
First
item, if item is a string, then item 0 is going to be A. So here we can test if item 0. So this is A, but we need a logical statement saying whether
in
this
vowel.
thing.
In
That's
vowel.
right. Exactly. So if this letter is in the list vowel, right? Then this will return true, right? So we can kind of play around with these, right? Right, so A is in vowel, right? What about, so item 1, right, is P. So this should be false, right? 0, 1, 2, 3, 4 is E, that should be true, right? So you can play around with that. So we're gonna use this as our, to test whether the word starts with a vowel or not. So if item 0 is in vowel, then what do we want to do?
Would you like N?
Right. And otherwise, would you like right? So now if we run this, would you like an orange smoothie? Would you like a pear smoothie? Would you like a banana, a kiwi, an apple, a banana? So that works. Okay, so here's an exercise for you. Let's I want you to try this now. I have this code here. It's slightly different. I just create a variable article A, and then if item in produce, oops, sorry. If it's a vowel, if it's in the vowels, then the article is changed to an, and then I just print the statement once. Would you like article, and it's either A or an, right? And then the fruit smoothie. So it's the same, it's just another way to write it. but let's say ice cream is available with banana and kiwi. So for these two fruits, let's output, would you like a banana smoothie with ice cream? Would you like a kiwi smoothie with ice cream? But for the other fruits, just output, would you like an, would you like an orange smoothie, etc. So how can we, and we want to keep this part as well. So how can you adapt this code to add with ice cream to banana and kiwi? So go ahead and take a minute to do that, to do that. Okay, anybody have a solution for this one? So if item equals banana or kiwi, then would you like an with ice cream? Right. So okay, so this equals banana or kiwi. We can do this a couple of ways. So let's just keep this let's have another variable here called sentence end. So the sentence end will be smoothie. And then if the item begins with a vowel, then we change the article to an A. And if the item is banana or kiwi, then let's change the sentence end to smoothie with ice cream. Right? And then here we can just add in sentence end. Right? And so if in the case of banana or kiwi, the sentence end will be smoothie with ice cream. In the case of other fruits, it'll just be smoothie. What's wrong with this statement though?
If or item equals kiwi.
Yeah, so we can't use the or to kind of create a list of things that kiwi might be equal to, right? So we can do this in two ways. We could either do like this, right? If item equals banana or item equals kiwi, that would be fine. Or we could also do kind of a statement like this. So we create a list, fruits with ice cream. Okay. And then we can, how would we change this statement here? Using this variable or this list. So we would use the in operator. Right. So here we're using the in operator again. And if the fruit is in this list of fruits with ice cream, then we change the sentence end, right? So I like this. This code is kind of elegant for a few ways. Number one, you're only using the print statement once, right? Because this would start to get really complicated if, for example, if some of these need an A, some need an and, some have smoothie with ice cream, right? And this allows you to change different parts of the sentence based on some criteria around the item in the list. And then once all of those parts are decided, then you can put them all together finally in the sentence, right? So let's run that. And so, oops, what do we do? Why are we having only bananas? We need to refresh our. Why is this saying banana? Oh, sorry, it should be item. Okay. Right. So would you like an orange smoothie? Would you like a pear smoothie? Would you like a banana smoothie with ice cream? Would you like a kiwi smoothie with ice cream? So on and so forth. Okay. So, okay, last exercise with this. Let's create a fruit count. So what I want to do is I want to create an empty dictionary called fruit count, whose key is a fruit, and then whose value is the number of that fruit. And then we're going to loop through produce, our fruits list, and using the for and if to update the fruit count. So here, so the first item in my fruit list is orange, right? So fruit count is empty. So that when I encounter orange, what do I want to do with that? How am I going to add orange to my fruit count and then update the value to 1?
Use append.
So for lists, I would use append, but fruit count's a dictionary. So the first time I encounter something, I want to add the item and set it equal to 1. Right? So that's fine. Like if I do that, then each time I encounter the item, I will add it to my list and set it equal to 1. So 1 orange, 1 pear, 1 banana, 1 kiwi, 1 apple. The problem is my list has 2 bananas, right? So the second time that I encounter a banana, I'm adding that item to my fruit count and setting its value equal to 1, right? But that's not what I want to do, right? I want this banana to say 2. So what do I need to do here so that my fruit count can update fruit that are already in my list, or sorry, already in my dictionary?
Fruit count value.
Yeah. So I want to check if this fruit is already in my fruit count or not, right? So if the fruit is if the fruit is not in the fruit count, then I want to do this, right? Then I want to add the item and set its value to 1. But if the if item is already in my fruit count dictionary, then I don't want to do this. Then I want to update the count. So how can I check if this fruit is in the fruit count dictionary? Any thoughts? This is the fruit count dictionary.
Maybe if
Yeah. Mhm.
if item in fruit count key.
Yeah. So if item is in fruit count keys, and we know that for dictionaries, if you just write item in fruit count like that in the dictionary, it's going to check the keys anyways, right? So all I want to do is check if the item is in fruit count already, then what do I want to do? What do I want to do if the fruit is already in the fruit count?
Measure the length and then add value.
Yeah, I don't actually need to measure. I don't actually have to check the length. I just want to, if it's already in there and this number is going to be 1 or greater, then in that case, all I want to do is update the count, right? So in that case, I can just plus equal 1, right? Which is the same as taking the current count and adding 1, right? But so that's all I want to do. If it's already in the list, then I want to update the existing value by 1, right? If it's not in the list, then I want to put it in the list and set the value equal to 1. Okay? So this is a case where, as I'm looping through items in the list, if it's the first time I am encountering it, then I want to add it to the list, set the value equal to 1. If it's already in the list, I just want to update its value by 1. Okay? So this should now see orange 1, fair 1, then now that banana is 2. Right? So this is another example where you're updating counts. You have to instantiate it the first time, and once it's in there, then you're just updating. Just another kind of combination. Okay, you can also use if in a while loop. So let's refresh our produce. So another way to do this, remember earlier I said you can use this for and if, but you can also use while and pop the values in the list. So here's fruit count again. We're going to do the same thing, but we're going to pop. And so the condition here is whether we still have fruits in the list, right? So while the length of fruits in this list is greater than, is not equal to 0, right? Or we could say is greater than 0. As long as we have items left in this list, then let's pop the item. So I'll just call that item, and I'm going to I'll pop whatever fruit is at the end of that list. And then if the item is not in fruit count, then it's the same logic as here, right? If the item is, well, I did it in reverse here. If the item is not in fruit count, then we'll add it and we'll set its value to 1. Otherwise, we'll just update its value, right? And then we'll go back and if we still have items in the list, right, if the length is greater than 0, we'll pop the next one, add them, etc. So this will do that. And now we get banana, 2 bananas. It's the same count. It's in different order because pop takes items from the end of the list, whereas the for loop kind of loops from the beginning of the list. But in terms of the keys and the values, it's the same. One note I wanted to make about this, this length of items in the list being greater than 0, there's actually a kind of a fun thing that Python does. So the Boolean value lists have a Boolean value. And if the Boolean value of an empty list is false, so here's an empty list, am I empty? And it's an empty list. And if you run the Boolean of that, it's going to return false. But if that list has something in it, right? So here's a list with one item, the number 1. The Boolean of that is true. So you can run like a Boolean on a list, and if it's empty, it'll return false. If it's not empty, it'll return true. So you can actually run this. Let's refresh our produce. And so here we got rid of the length is greater than 0. And all we have to do is put in produce fruits. And as long as there's something in this produce fruits, we can pop it and we'll keep going through this while loop. But once we've popped the last item and this produce fruits is empty, then the while loop will end. Right? So it's the same code as before, right? So we get that. And if you wanted to see, we can print produce fruits as we're going. Let's refresh. Right, and you can see like each time we're popping the item that we're popping. So this is the item that we're popping, and this is how many we have left, right? And then, so again, you can use the while loop with pop if you want to one by one take items out of your list and do something with them, right? But if you still need that list intact at the end, then it's better to use the for loop because the for loop doesn't right, that for loop, it's gonna loop through them, but it doesn't change the list. The list stays the same all the way through, right? So that's this difference between pop. Okay, we also have a break statement. So a break statement allows you to exit the recursive loop. So if we're looping through this list, so list of fruits, there's orange, pear, banana, kiwi, apple, banana. We're going to print the item, and if the item is equal to kiwi, then we're going to break, and so that will end the for loop once we encounter the item kiwi. So orange, pear, banana, kiwi. So here I just changed the order of the code. What's this going to be? What's this going to do differently than the one above?
Kiwi won't be printed.
Yeah, so here we're going to break before we print, right? So again, you have to kind of be careful like where you put the break statements and everything. But this allows you to exit a loop given some kind of condition, right? Okay, so here's one exercise. So let's pop the first 4 fruits from our produce basket into a fruit count. and report how many fruits are in the fruit count, and then show which fruits are left in our market basket. And here we're going to do if and the break statement. So we're going to use our fruit count here. Um, so let's pop the first 4 fruits from our fruit basket into a fruit count, and report how many fruits are in fruit count, and then show which fruits are left in our market basket. So here, so actually, I think it's better not to use the, so if we're going to be using pop, then we should be doing this with while, sorry. So let's use the while. Okay, so we've got, let me refresh our fruit basket just to make sure. Okay, so we're going to pop the first 4 fruits from our basket into fruit count. So how are we going to make sure we only pop the first 4 fruits? So here fruits are orange, pear, banana, wiki, apple, banana. Right. So here we can use length. So before we're using length greater than 0, here we can use we can repeat this as long as the length is greater than what? Pop the first 4 fruits. So length minus 4. So how many, we want to stop this loop after we've done 4. So let's say there are 6 and then we pop it, right? We pop 1, now there are 5, we pop a second one, there's, so the length of, let's see.
Maybe it should be greater than length minus 4.
Yeah, so let's do, but the length of this is going to be changing, right? So we can say the length, so length is, this will be the original length, right? And then while the original length is, so, and then each time we're popping, right? Length minus, so length minus the length of that will go down to, so it would be like 6 minus 6 is 0, 6 minus 5 is 1, 6 minus 3, let's see, 6 minus 2, 6 minus 3. So once the length minus the length of this is greater than 4, Let's see if that works. So this is, say this is 6, and then we pop like 4 times, and now we have 2 things left. So length minus 2 is 4. Okay. So then, and then we'll do this. So let's try this. Oops. Six. Let's let's do it while it's less than 4. Oops. Yeah. Okay, that works. So the original length is 6, and then once we pop once, twice, 3 times, this length minus this thing is going to go up. So it's going to go from 0, 1, 2, 3, and then once we popped 4 times, then the length minus the remaining length will be greater than 4, or 4 or greater. So this is just one way to index. How many you've got left. So there's another way we could do this is we're adding items to fruit count, right? So these counts. So we could also, instead of doing this, we could add the sum of the values of fruit count. So I don't think I want to do that right now, but that's another way you could do it, is you could add, 2 plus 1 plus 1. And once the sum of the values of fruit count are greater than, or 4, then you could stop the while loop as well. So, okay. So now we have nested repetition statements. So here you can use for and for. You can use for loops inside of for loops. So let's refresh the produce again. And now we could use for fruit in fruits and for veggie in veggies. We're going to print fruit and veggies. So what's this going to give us?
The list of fruits and vegetables.
Yeah, how many items is this going to print out?
9.
9.
Okay. So we're going to go through, this is nested though. So for each fruit, we're going to loop through all of the veggies, right?
18, I think.
Yeah, it's going to give us 18 because first we're going to take orange and we're going to loop through cabbage, carrots, asparagus. Then we're going to take pear, and then we're going to loop through cabbage, carrots, asparagus again, right? So this is going to give us 6 times 3, right? So this is 18 items, right? So, and you can see here it's taking orange, orange, orange. So it's orange, cabbage, carrots, asparagus, pear, cabbage, carrots, asparagus, banana, cabbage, carrots, asparagus, right? So this is giving us 18 items. I'm just going to add some syntax here. Would a orange and cabbage smoothie be delicious? So probably a fruit and vegetable smoothie would not be so delicious in sometimes. So what if I just want to have a fruit smoothie with 2 different fruits, right? So here I can list, I can loop through my fruits, and I can loop through my fruits again. What I have to be careful about though is that this variable has to be different, right? Because if I have fruit here and I have fruit here, right? If I use the same word, right, it's going to give me orange and orange, pear and pear, banana and banana, kiwi and kiwi, apple and apple, right? What this is doing is it's taking the fruit orange for the fruit orange, and then it's taking, and then it's looping through all the fruits, right, which are orange, pear, banana, kiwi, apple. So these, but this fruit is actually getting lost, right, because it's being redefined as this fruit. And so, and then when you put fruit and fruit here, it's actually going to have it twice. So what you want is to give these separate names, right? Like this, right? And now you're still going to get, how many items do we have here? How many items are going to be on that list? We have 6 fruits. How many?
36.
Yeah, we're going to have 36 items here because we're looping through 6 fruits times 6 fruits again, right? So, but what if, notice that some of these, like orange and orange, are the same, but some are different, right? So orange and orange, pear and pear, banana and banana. How can we avoid, how can we rewrite this code so that you avoid identical pairings?
Maybe if fruit 1 equals to fruit 2, then break all, or
So if we break, then the first time that we encounter that, then we're gonna exit, right? So if we break, right. So this break is tricky because break only breaks out of the first four, out of the most, it doesn't break out of both loops. It only breaks out of one loop. So break is really complicated when you're using 2 nested for loops. For example, here, if you break here, well, now you're going to run the first line, but then orange is going to make it break. So you'll only run like one. Oops, what happened here? Ran it. Oops. Oops, sorry, section here. So here you're getting orange and orange, and you print.
Can we use continue?
Yeah, so I think here,
In the second loop.
I think here, just to avoid the identical pairings, there's a much simpler way to do this. You can just test if fruit 1 doesn't equal fruit 2. Right? So as long as fruit 1 doesn't equal fruit 2, then we'll print this out. Right? And so how many will this give us?
I mean, 30.
Yeah, so it's going to be 6 times 6 is 36, except we're going to omit the 6 cases where they're the same. How could you index these like 1, 2, 3, 4, 5 if you wanted to? So one easy way, I mean, this is kind of a quick and dirty way to do it, is just to create an index, right? And then after each case, just the index, like update your index like this. Yeah. Arturo? The exam will be tomorrow after. So you can, here you can index each output statement. You can create an index and then you can update the index each time that you execute this. So, and then you can include index in the, so this will give you like this. Right. Okay, one other thing, notice in here, we have orange and pear, but then we have pear and orange, right? What could we do if we want to avoid the duplicate pairings, which are in the different order? Any thoughts, any ideas about how to do this? So we want to avoid identical pairings and duplicate combinations in reverse order. So one elegant solution for this is actually it's just to use less than or greater than. And so here, because the not equal sign is going to avoid identical pairings, the less than sign is going to put these in alphabetical order, right? So if orange and pear, O comes to LM and OP, so orange would come before pear, right? So this way, orange and pear would appear, but pear and orange would not appear, right? So I actually use this quite a bit when I'm doing when I'm pairing names, like to make like or like ties in a network or something, where I don't want to duplicate the opposite direction, right? So orange and pear, pear and orange, but I only need one of those instances. So I can use the less than sign, and that'll accomplish both of these things. It'll avoid identical pairings, and it will avoid duplicate combinations in the reverse order. So that will give us this. Yeah. So we get orange and pear, banana and orange, banana and pear, kiwi and banana, and let's index these real fast just to see how many we have here. We can index with one because we're not Python. Right, and that gives us 14 instances. So, okay, great. So this is for loops nested within for loops. It's tricky. Also, it's very computationally intensive, right? Because you're going to do, it's a n squared, right? It's the number in one list times the number in another list. And you can quickly like start getting into really large, numbers here. So let's talk about comprehensions. So a comprehension is it's a way to construct a list from another list or dictionary from another dictionary. Comprehensions are convenient and very Python way of dealing with repetition, particularly with simple tasks. Right? They avoid we can use them instead of for loops and lambda statements. So I'm not going to talk about lambda statements today, but there are two different, so there's list comprehensions and dictionary comprehensions, and the formula here is this. It's a list variable, and then there's a, you're going to use the square brackets with a statement for E in the list, for the element in another list. So for example, you've got, let's say you've got, let me refresh my produce. List comprehensions are extremely useful. Okay, so say I have fruits are here. I just want to deal with the list right now. Okay, so I have my fruits list here. Let's say I want to add the word smoothie onto every item of this list, right? So I could, I want to create a list called fruit smoothie. So I'm going to create a list. Here's my notation. So it's a statement for E in list, in my list variable. So I'm going to take my original list fruits and for E in fruits, right? First of all, let's just run that. Oops, sorry. So if I just take this statement for every item in fruits, that item, this is just going to reproduce the original list, right? So this is one way to reproduce the original list. But say I want to add on smoothie to every item in this list. So this statement on the left side of 4 is where I can start doing things, right? So if I want to add on plus smoothie here, so for every element in fruits, take that element and add smoothie, right? And now I've got orange smoothie, pear smoothie, banana smoothie, kiwi smoothie, apple smoothie, banana smoothie. So this is a way to, this comprehensions is a way to construct new lists based on old lists. Okay. You can also add an if condition at the end, right? So for example, let's say there's some fruits I dislike. For example, say I dislike kiwi and I dislike apples, right? Now I want to take, here's my fruit. I want to reproduce my list minus the fruits I don't like. So here I can, fruits I like, I'm going to take the original list of fruits for E in fruits. Right, so that reproduces the original list. But here at the end of the list, I'm going to add this if condition. So if E, because E is the element that I'm grabbing here, if E is in this list of fruits I dislike, okay. Okay, so for E in fruits, if E is in fruits I dislike, then add it here. So this is actually going to give me the fruits I don't like, right? So here, if E is not in fruits I dislike, now I've reproduced a list of fruits I do like, right? And then if I want to make, so adapt this code, make smoothies, make a list, fruit smoothies I like, okay? So how am I going to adapt this code to make a list of fruit smoothies? I want to add smoothie but only to the fruits that I like. So what's that fruit? What's that list comprehension going to look like? Yeah, perfect. So I'm just going to take this code, and then I'm just going to add the smoothie part. So this is going to give me orange smoothie, pear smoothie, banana smoothie, and another banana smoothie. Okay, so you can also do, so we should do a lot more with list comprehensions and dictionary comprehensions in the future. I just want to introduce those today because they really combine, they're combining lists, constructors, plus for plus if statements all together. And they're much more versatile. So you could have done this the same way. So let me add an exercise here for the homework, which will be instead of a list comprehension, use for and if to create fruit smoothies I like. Right. So here's the fruits I dislike. Right. So we use a list comprehension to do this, but adapt this code, right? Use the for and if statements to create this variable, right? It's the same. It's going to result in the same thing, but the exercise is to show how much kind of simpler using a list comprehension can be. So additional exercises for tomorrow. Write code that creates this sentence. Your fruit basket contains 2 bananas, 1 apple, 1 kiwi, 1 pear, and 1 orange. So we did parts of this earlier. We created a sentence that said our fruit basket contains banana, apple, wiki, a banana, an apple, a kiwi, a pear, and orange. But I want you to now combine the other one that we use, this list, sorry, the fruit count dictionary that we constructed up here. Where was it? Yeah. So we constructed this fruit count dictionary here. So you can use that fruit count dictionary and then write this sentence. So write the code that would reproduce the sentence, and note that the number should go in front of it. And also you need to add an S onto items that have a plural count. So if there's more than 1 banana, it needs to have an S, right? If it's just 1 apple, no S. And also add an and before the final item. So this and also end it with a period, right? So this is the exercise number 1. It seems pretty simple to construct that sentence, but we're actually going to have to combine several things. And lastly, this is kind of a very like a fun, challenging exercise, is to create a fruit market receipt. So here are some fruit prices. I'm going to give you for orange, apple, kiwi, and pear. Oh, I should put banana in here as well. Let's say bananas are 25. So, and then your sales tax is 10%. So I want you to use these fruit prices to create a receipt. So if produce is our produce basket, then print out a receipt to show which fruit were purchased, how many of each fruit were purchased, what was the unit price, what is the subtotal for each fruit, and then you can add a line underneath this showing the sales tax is 10%, and what is the subtotal. So it's going to be, you know, the subtotal what is the subtotal for all fruit, and then the sales tax. And then you can add all of those things, the subtotal for the fruit plus the subtotal for the sales tax to get the total bill. And then if you like, you can add some formatting elements like a $sign or different like lines or something separating the parts of the bill, and you can be creative and have fun with it. And if you want, wrap all of this in a function called produce receipt, print receipt. And the parameters for this will be fruit prices and fruit list, right, or fruit basket, right, and sales tax. So this is kind of a extra, or kind of a bonus to create a function with these. So the fruit prices, you can insert this dictionary, and for fruit basket, it's going to be your produce basket, your produce fruit, and then the sales tax will be this. So these three things go into the function, and then you should output the receipt. So this is definitely the most complicated task we've done to this point, but I'll upload this updated one to the Moodle and to Python, sorry, to GitHub. So any questions about these exercises? So if you have any questions, you can just upload them to Telegram, and then I'm happy to kind of work with you, or if you get stuck on something, just let me know. Apple, orange, kiwi, pear, banana, I think that's right. So, okay, if no questions, I'll update this in GitHub and Moodle, and I will see you guys tomorrow.
Thank you.
Thank
Goodbye.
you.
Okay,
Bye.
goodbye.
Thank you.